Page 276 of your student journal. Today we're dealing with properties of radicals. I want you to complete exploration number 1 on page 276. Work with partner. You're going to spend about 5 minutes or so on it, so don't take a lot of time getting set up on it. All right, Quentin, what'd you get right here? Okay. Square root of 36? 6. Okay, Zach, grab it right here. 8. And Kaylee, what'd you get here? What's 36 and 64? 100. What's the root of 100? 10. Is 6 plus 8 10? No. Okay. So in general, does root A plus root B equal root A plus B? No. Okay. Here is a counter example for that. No, it does not work out. Okay. Let's try multiplication. What's the square root of 4, Vincent? 2. And we get 9, Mercedes? 3. And we're going 2 times 3. And 4 times 9 is what? 36. Square root of 36 is? 6. Did that work out?
Yes.
Yep. So in general, based on what we've done so far, is that true?
Yes.
Yes? Mercedes? Try different ones? So, say, which numbers did you use? So root 12 by root what? 9? And so she's trying other numbers out. So we don't want to just say it's true based on one thing. So if we did 12 times 9, that's 108, right? And so if you do root 12 times root 9, so that'd be 3 point something times 3. I don't know what the exact root of 12 is. Okay? That would have to be around 10 point something. The square root of 100 is 10. Okay. So, Kai, can I borrow your calculator? Let's try it out. Root 12. Good. We apply that by 3, we get 10.39, and then we do the square root of 108. You can work out. Could have just been a minor math error, but you definitely want to try other numbers out. Okay? So, yes, it will work if you want to multiply. How about subtracting? Did it work? No. We get 8 minus 6, which is 2, and 64 minus 36, which is 28. The square root of 28 is not 2, therefore it does not work. All you need is one counter example. That's a good counter example. Did division work? Yes, 10 divided by 2 is 5, and that is root 25, which is also 5. Good. Okay, so 5 equals 5. We're good to go. All right, so in general, which things can you just which things can you put together inside your radicals? Multiplication and division. So if you look at page 277, how can you multiply or divide square roots? Okay. I want you guys to go ahead and spend some time filling out questions 3, 4, and 5 there.
And B.
Yeah, man.
What is that? Like, what does it mean by that?
How can you multiply and divide square roots? What do you multiply?
The square root? No, the numbers getting squared.
One's inside the square root. Maybe list some examples for yourself. All right. Multiply or divide the numbers inside the square root symbols and take the square root, the product, or the quotient. Okay, in general, kind of what they were showing on the previous page, a times the root of a times the root of b is equal to the root of a times b. And the root of a divided by the root of b is equal to the square root of a divided by b. You can just multiply these numbers together and take the root, or divide them and then take the root. It'll be the same as taking the root of each of them individually and or multiplying, dividing. All right. I want you to take a look at page 278 of your student journal. 278 has some different notes that you could be going through, or you could be adding to as you're going through today's lesson. Okay? We've already talked a little about counterexample, where you show an example of something that is not true. We did that with the plus and minus ones. Radical expression, we've seen some of those. Simplest form, we'll talk about. Rationalizing the denominator, we'll talk about. And conjugates, those are probably all brand new terms right there. Okay? And like radicals, means you have the same thing under the radical symbol. Okay, so as we're going through our problems today, I want you to maybe flip back to that and add to your notes. All right, so on page 279, we're going to work through some of these together. Number 1, okay? I want you to talk to your neighbor about what you have to do on that one.
Number 1.
Okay, what do you do? Number 1.
Find the square root.
You do not. Okay, what's the square root of 24?
4.96.
Not allowed to round.
4.8.
So you keep going on forever, right? So we're simplifying the radical. Simplifying the radical means you are breaking it down into simplest form. It's kind of like simplifying a fraction, but it's a radical. The way you do that is you first have to figure out if you're dealing with a square root or a cubed root or what type of root you're dealing with. Okay? We know this is a square root. How do we know it's a square root, not a cubed root? There's no 3. If there is a little 3 in the index spot right there, which you can't see, okay? If there is a little 3 right there, that would be a cubed root. Okay? However, there's not, so it's a square root. If it was a cubed root, you're saying what times itself 3 times makes 24. Here you're saying what times itself 2 times is 24. Okay? If you don't see a little number there, it's implied that it's a square root like that. Those are the same thing. Now, what I need to do is I need to figure out, if I'm going to simplify this, I need to figure out what perfect square numbers go into 24. So in order to do that, let's make sure we know all the perfect squares. Right up above extra practice here, I want you to list all perfect squares from 1 through 15. The first 15 perfect squares. I'll give you a hint. There's the first one. 1 times 1 is 1. So you list the next 14 perfect squares. Okay, first one is what? After that?
9 times 9.
You're listing the first 15.
Oh my god.
Oh, that makes more sense.
Okay, good.
All right. There's the first 15. That means 15 to the second power is 225. 1 to the second power is 1. You have your checkpoint in between, 10, 5. Okay, keep going, but what you're trying to do when you're simplifying a radical is try to figure out which perfect squares go into 24. Other than 1, we kind of ignore 1 because 1 goes into everything. So, looking at 24, if you don't know your math facts well enough to know what number goes into it, then you grab your calculator and do 24 divided by 4. See if 4 goes into it. If it doesn't, then try 9. And if it doesn't, try 16. Okay? Those are the only numbers you care about right now. So, one perfect square goes into 24. 4. 4 times what? 6. So we can break 24 into root 4 times root 6. Square root of 4 times the square root of 6. The benefit of that, what's the square root of 4? 2. We're now done with that one. Is there a perfect square that goes into 6?
Nope.
No. Therefore, we're done with that one as well. I circle them when I'm done with them. That we would write in final form as 2 square root 6. That is our answer. 2 times root 6.
Why square root 6?
Because the square root is
Thanks.
No perfect square.
Thanks for the answer. I want to say thanks.
Okay.
Say thanks to him.
I understand. I kind of understand.
Questions? Okay, I want you to try number 3. Number 3. Let's break this apart. That's the first thing we're going to do. We're going to call this root 162 times root g to the 6th. Now I'm going to deal with those 2 different ways, or at 2 different times, excuse me. Root 162. If I try 4, does 4 go into it? For those of you that want the quick shortcut to know if 4 goes into something, if you cut it in half evenly twice. So if I cut 162 in half once, it's 81. I can't cut it in half again. So 4 doesn't go into it. Does 9 go into it?
Yeah.
Yep. And if you want to know the rule for 9, if you take 1 plus 6 plus 2, add all the digits up. If 9 goes into the number you get, 1 plus 6 plus 2 happens to be 9, and 9 goes into 9. Therefore, 9 will go into 162. Okay?
That's true.
Yeah, that's true. Okay? All numbers that 9 go into add up to a multiple of 9. Okay? So, one way to do this then is to break it into 9. Use 9 here. Square root of 9. 9 times what is 162? Happens to be 18. Okay? You could have. That's a good question. We'll get back to that.
I did that.
Okay? Bella asked, she said, couldn't you use 81? You could have. If you use a bigger square root, a bigger root, then you won't have to do as much work. Okay? But if you're just testing the numbers in between, then if you just tested the 9 and you found that worked and went this route, you would get to here and say, well, that's 3. And then you'd have to say, does anything perfect go into 18? Yes?
Yeah, 9.
Yeah. Root 9 by? Root 9 by root 3. That is 27. It is 2. Okay? Root 9 by root 2. Square root of 9 is?
Because 9 times 2 is 18.
Any perfect square going to root 2? Nope. We're done there. All right. So this right here, we're done with this part. How about g to the 6th? Is there anything that you can multiply by itself to get g to the 6th?
G to 6.
How about g times g? What's g times g? G squared. So I'm gonna make a little list here real quick. G times g is g squared. All right. So that means g squared is a perfect, like the square root of g squared we could do. It's g. Right? Okay. How about g squared times g squared? What's that equal? It's g to the 4th. So the square root of g to the 4th is what? G to the 2nd. Okay, well what's g to the 3rd times g to the 3rd? G to the 6th. This is g times g times g. And this is g times g times g. That's g to the 6th. Okay, what's the square root of g to the 6th? G to the 3rd. Okay, what's the next perfect root going to be for g? Look at your pattern. G to the... Well, this is going to be g to the what? 4th, which makes this g to the 8th, which that's g to the 4th times g to the 4th.
Cool.
It's g to the 8th, square root of g to the 8th, g to the 4th. What do all of these numbers that are inside your radical that are perfect roots have in common? They all go up by 2. They're all what type of numbers? Even numbers. The only perfect square when you're dealing with variables are even powers. Okay? So, I come back to this problem. Is this a perfect square?
Yes.
Yes. What's the square root of it? It's g to the 3rd. You just cut it in half. We're now done with that part.
You didn't even know what lesson we were on.
Okay, I want you to write your final answer down, please. Write down your final answer.
It would be G.
Would it be times 3 or plus 3? Plus 3 or
Okay, so final answer, we'd have that 3. We'd have that 3. They are multiplied. We have that root 2. And we'd have that g cubed. We do not write it like that, however. We put everything that's outside of the radicals in front. So that would be 3 times 3, or 9, g cubed, root 2. That is our final answer. 9g cubed, root 2. Sarah? We'll deal with that when we get there. Okay? Okay, I want you to move on to number 5, please. Number 5. Actually, you know what? Let's do 4 first. Number 4. Okay, break it into its 2 separate parts. Actually, 3 separate parts right now. Tell your neighbor what 3 separate parts are going to be.
Negative 512 h to the 2nd. Yep.
Okay, one of them is 512. One of them is h to the 7th. What's the other one? Negative 1 is out in front. So we're already done with negative 1. We circle it. We ignore it now. Okay? That negative just means negative 1. We're done with it. We use it at the very end. We don't deal with any more of it. 512. Actually, let's go on to the variable real quick since we've just been dealing with variables. Is that a perfect root or a perfect square? Nope. What's the closest number that is perfect to it? 6. 6 or 8. You're not allowed to go over, though, so it has to be 6. We're going to call it h to the 6th times what? H. So if it's an odd power, you're always going to have one piece left behind. You're going to break it to an even and have one piece left behind. What's the square root of h to the 6th? H to the 3rd. You're now done with that part. Can you do anything with h to the 1st? No. You're done with that. So we're done with the h's. 512. Figure out what goes into it. If you use your rules that I told you, does 9 go into that? 5 plus 1 is?
6.
6 plus 2 is? 8. 9 doesn't go into it, meaning what other perfect square won't go into it? 81, because 9 times 9 is 81. Okay, 81 won't work. Can you cut that in half once?
Yeah.
Yeah, it's even. What's that when it's cut in half?
No,
What's half of 500? 250 and half of 12? 6. So 256. Can you cut 256 in half?
Yes.
Yes. What is it? 128. That means root 4 by root 128 goes into that. You could.
It's great.
I understand like math.
Cool. Okay. Root 4 is 2. Root 128. Does 4 go into it?
Maybe.
Cut it in half twice. What do you get? Yeah, you get 32. So root 4 by root 32. Be quiet.
Sorry.
Thank you. Okay, that becomes 2. The square root of 32. Will perfect square go into that?
32. Yeah.
Come on.
4 can.
No, come on. We can't use decimals. 4 goes into it, but we're close enough now. You should know another perfect
16.
square. 16. We could keep using 4, but it takes longer, right? Root 16 by root 2. Everyone see why we circle all the pieces? Makes it easier at the end. So, outside of your radical, you have a negative 1 times 2 is? Negative 2 times 2. Negative 4 times 4. Negative 16. H cubed. What's in the radical? 2 and H. Now you're done with it. It would have been a lot faster if you would have recognized early on that 16 goes into, 256 goes into that. 256 is a perfect square. It goes in twice. It makes it a lot easier. Square root of 256 is 16. So if you would have recognized right away that 512 is root 256 by root 2 and that this is 16, you'd have 16 root 2 and you're done. Root 2. That'd be a lot faster. Yes?
Would it be negative?
You always leave it in radical form unless it's a perfect root. Yeah, you can't change it to a decimal. Never-ending decimal. Non-terminating. This one's in the root, so we have to put it in the root at the end. Because the root of 16 is 4. The 4 is not in a radical symbol. See, so there's not a root symbol over the 4. Therefore, we don't put it in the root at the end. Okay? All right. I want you guys to give number 5 a go. Okay, time's up. What's the answer? 5/8, yes. Root 25 over root 64. 5/8. Okay. Move on to number 7. Give number 7 a go. Okay, which one was perfect? 196?
No. Never mind.
What is that? 14. What else is perfect? R to the 4th is R squared. And the negative sign just carries out and you put it on at the end. There you got it. All right, we're going to skip the bottom row for a minute. We'll come back to that part tomorrow. Why don't you take a look at number 13 on the next page, please.
Yes, we get to finish this.
Number 13. Okay, tell your neighbor what you're going to do.
We get to finish this page. Okay. Wait, and about the square root of 15. Square root of 500. And then.
Okay, can we simplify 15?
Yes. No.
No.
No, how about 100 or 500?
I don't know.
Yes.
Yeah, you could. You could break 500 down. 500 becomes what? You can go 5 times 100, right? Hey, but if you can't break both pieces apart, try to reduce it first, unless they're already perfect. Neither of these are actually perfect. But is there a number that goes into 15 and 500? 5. How many 5s go into 15? 3. So that would become root 3. And how many 5s go into 500? Yeah, 100. How does that help? Well, the top is now root 3. What's the bottom? It's just 10. Yeah. Square root of 100 is 10. That's our answer. It's okay to have a radical in the top, but if you ever get a root in the bottom of your problem, that's bad. Can't do that.
What would you do?
You'll find out, but you can't do that.
You just can't do it.
I want you to give number, for your assignment actually tonight, I want you guys to do number 14, 15, and finish the front page with the exception of 9 through 12. Okay, so 14, 15, you need to, the ones we haven't done on the front were 2, 6, and 8. 2, 6, and 8. The bottom we'll do tomorrow. 14, 15, then we'll do these other ones tomorrow, and then you need to do 22 through 27.
Wait.
Do what you think you should do on those problems.
So we basically do this whole page.
No, you don't basically do that whole page.
No, you do 14, 15, 22 through 27.
Thank you. Okay, 2, 6, 8, 14, 15, 22 through 27. Okay? I'll write it down for those of you who didn't get it.
Oh.
23 and 24.
2,
22
6,
through
8.
27. That whole section right there. There you go.
There you go.